The other way of doing this sort of equation is actually using the t results. The advantage of using t results, you end up turning a trig equation into a polynomial equation. Same equation as we saw that before. 3 cos theta plus 4 sin theta equals 2. Well, I'm going to let t equal tan theta on 2. So my t result for cos theta, 1 minus t squared on 1 plus t squared, and sin theta, 2t on 1 plus t squared. See, the nice thing about using t results is the denominator is the same in the t results for both cosine and sine. So I can multiply out by the denominator and I end up with a quadratic equation. And we know how to solve quadratics. There we go, 5t squared minus 8t minus 1. But notice what I've done over here. Theta, remember we're looking for answers between 0 and 360. So as soon as I change it to t results, I am only looking for answers in the first or the second quadrants. So 0 and 180. It's not a nice neat number, but okay. So either tan theta on 2 is 4 minus root 21 on 5, tan theta on 2 is 4 plus root 21 on 5. Now the nice thing about only looking in the first or second quadrant, tan is positive in the first quadrant, tan is negative in the second quadrant. So straight away I can look at this and know, am I talking about an obtuse angle? Am I talking about an acute angle? This one here, 4 minus root 21, yeah, root 21 is bigger than 4, isn't it? Has to be, yes, 4 squared 16. That's a negative number. So I know that is an obtuse angle. The first one, 4 plus root 21, is a positive number. So it's got to be acute. So that one I know is in quadrant 2. Because you've got to calculate, you probably don't need to do this middle step here. Because if you just plug that number in, the way that calculator works, because it's working with an inverse tan function, it would just give me negative 6 degrees 39. But it's still going to give me the acute angle, and remember we want the obtuse angle. So whether you change it to a positive number and find the obtuse angle, or you just go to your calculator and you know, oh well it's giving me the negative, but that's the acute angle I want. And maybe it's handy it comes out with a negative number because you're going to take it away from 180. So all you got to do is add the 180 on. There it is, 173 degrees 21. Double it, and there's one of our answers. Now we go to the other one. But that will give me the acute angle that I'm looking for, 59 degrees 47. Double it, there's the other answer, 119.33. The one thing you have to be careful of with this method, you always have to check, is 180 degrees a possible answer? Because the t results will not find it. Reason? You have let t equal tan theta on 2. Well, if theta is 180 degrees, theta on 2 is 90 degrees, and tan of 90 is undefined. So we would never find that answer for you. You need to do a check, but the check's not that hard to do. Here's our equation. Just think about what you're substituting into. We know the cos of 180 is negative 1. And the sine of 180 is 0. So really, all I'm looking at is the coefficient of the cos function. Now, because it end up being multiplied by negative 1, you say, well, is it opposite in sign to the constant on the other side? I'm looking at this one, I'd say 3. Well, negative 3, no, the other one's 2. So that's all right, 180 is not a solution. Had this equation been the same thing, but on the right-hand side was negative 3, then I would have gone, okay, I've got 3, so negative 3, oh, it's the same thing. That means 180 is a solution. So you just need to do a quick check. Be careful if you're using t results to solve these. So 11C, these ones we use in the t results.